G'day Halia Math students. This is the first video in the series for measurement, and in this video we're going to work on arc lengths. Now, the formula for arc length relies on the formula for finding the circumference of a circle. If we look here, we see here it is 2 pi r. But we're only finding a fraction of the total circumference. And to determine that fraction, we consider the angle at the centre of the circle. And because a full circle is 360, well, if we divide whatever that angle is by 360, we get that fraction of the circle. And that gives us the value for S. S means arc length. Now, I know that arc length starts with an A, and this is an S, but I suppose the letter A was already taken for something else, so they just decided to use S for the arc length here. So just like when you take a slice of pizza from the full pizza pie, you're removing a sector of that pizza, and the crust would be like, or the length around the crust of your pizza. So imagine a slice of pizza, and it's going to have toppings and stuff. That distance around the crust is your arc length. So let's try these examples. I'll go ahead and do the first one. If you want to pause the video at this stage and have a go at them on your own, you can, and then check your answers, or you can just watch this one first and then try the next couple. Okay, so S, the arc length here, is equal to 2 pi r. So 2 by pi multiplied by the radius of this circle, which is 6 centimetres, multiplied by the angle here. We say that angle subtends this arc length. That angle 45 degrees over 360 degrees. So here we've got our fraction of the circle. Okay, so let's put that into the calculator. You might want to pause and try and see if you can get the right answer. Then I'll write it down in just a moment. Okay, so the answer is to 2 decimal places. Not that that's entirely important, but I'll go to 2 decimal places. 4.71 centimetres. So we're dealing with a length here, so just centimetres. So it's 4.71 centimetres along this curved arc. Okay, so if you want to pause the video and try the next 2 examples on your own, you can, and then you can have a look at me doing them. Righto, so let's give it a go. For this one, we've got the arc length is 2 pi, oops, a daisy, by 8.7 is our radius, times the angle which subtends this arc, 132 on 360. And for this one, we get 20.04. And this last one, 2 pi by 17 multiplied by 240, whoops, on 360. And that one gives us 71.21 centimetres. So if you're still a bit confused about what's happening, well, one way to think about it is that the radius, so the number for the radius just goes on its own. Oops, that's not the radius. That's the radius there. So that goes on its own in the equation, in the middle like that. And the angle that's given, that always goes over 360. and then you put them into the formula, or the formula like that, and have a go at it on the calculator. So as usual, the questions for you to try are in the description for this video.